So let us start with the first exercise, 2.2 exercise of Pythagoras theorem. Now, in this question, there is no figure given to us, but a certain information is given to us. So looking at that, we are going to draw the figure. So in triangle PQR, so this is the triangle, and I name it as triangle PQ and R. There. S is the midpoint. S is the midpoint of side QR. So this is a side QR, and suppose if S is the midpoint, then I'll draw a line here. Okay. Then there are certain lengths of certain sides given to us, 11, 17, and 13. Let us write those. PQ is equal to 11. So PQ is equal to 11. PR is equal to 17, and PS is equal to 13. Okay? We are supposed to find out the length of QR. We are supposed to find out the length of QR. Now, also it has been given that point S is the midpoint, so I can show this by this symbol, which means that the QS is equal to SR. Now let us see how we are going to solve the question. If we look at the figure, children, we understand that we cannot apply our Pythagoras theorem here because there is no right angle triangle given here. So we are going to apply Apollonius theorem, the property of Apollonius, and according to which we are going to write down that in triangle PQR, let us write down whatever is given first. So in triangle PQR, point S is the midpoint of side QR. This is what we write first, and this is given. So we have written whatever is given first. Then we are going to write down the property here. Apollonius theorem says that PQ square plus PR square will be equal to 2PS square plus 2QS square. So let us apply that property here. PQ square plus PR square is equal to 2PS square plus 2QS square. You can also write down SR instead of QS. You can also write down SR instead of QS. Okay. In bracket, we'll write down the property Apollonius theorem. Okay. Then next, we substitute the values. PQ is equal to 11, so I write down 11 square, plus PR is 17, so I write down 17 square. PS is 13, 2 into 13 square, plus 2QS square. 2QS square. Now, let us find out. 11 square is 121. The square of 17, children, is 289. Is equal to 2 into square of 13 is 169 plus 2QS square. So let us do the calculations. If I add these, 9 plus 1 10, 8 plus 2 will be 10 plus 1 11, 410 is equal to 2 into 169, 9 2s will be 18, carry 1, 2 6 are 12 plus 1 13, 2 1s are 2 plus 1 3, plus 2QS square. Now, 410, 338, I'll shift it here because I want only 2QS. So, minus 338 is equal to 2QS square. So, 410 minus 338. So, this will be 10 minus 8 will be 2. Yes. This will be 7. So, 410 minus 338 will be 72. So let us write that 72 here is equal to 2QS square. Now I want only QS, so I'll bring 2 also here. Since 2 has been multiplied, it will be divided here. So 2q 72 by 2 is equal to 2qs square, which will be 36 is equal to qs square. Therefore qs is going to be equal to square root of 36. So our final answer will be qs is equal to 6. There is no unit given, so you can write down 6 units. But we are not supposed to find out qs, children. We are supposed to find out qr. So if you look here, qr is twice of qs. Yes. So we write down that. qr, I'll write down that here. qr is equal to 2 into qs. Since s is the midpoint, yes, we have written at the beginning only, so qr becomes twice of qs, which becomes twice into 6, which is 12. Therefore qr is equal to 12 units. This is our final answer. The next question that we have says that in triangle ABC, AB is equal to 10, AC is equal to 7 and BC is equal to 9. So I have drawn those lengths respectively. Then find the length of the median. So there is going to be a median here from point C to the side AB. So let us check out where are these points. Point C is here and side AB is here. I need to draw a median. Okay, so there will be a midpoint here, the midpoint of side AB, and then I'm going to join this line. Okay, I have to find out the length of this. Let me name this as suppose D. I want to find out the length of this CD. So whenever we talk about median, children, we are going to apply the property of Apollonius theorem. So what Apollonius theorem says that AC square plus BC square is going to be equal to 2CD square plus 2AD square. But I don't have AD here. Rather, I have entire AB. So my first duty is to find out the length of AD. So if D is the midpoint of AB, then AD is going to be half of AB. So let us write down and solve that first. So when we start writing a solution, children, we first have to describe a figure. So in triangle ABC, AB, AC and BC is already given to us. But what we have done is, we have drawn D on our own. So we'll first write down, let D be the midpoint of side AB. Okay, we'll say let AD be the midpoint of side AD. Therefore, we will say AD is equal to half into AB. Okay, which will be half into 10, which will be 5. Okay, so therefore our AD is going to be equal to 5 units. Okay, once we get this, we are going to proceed further and we are going to apply the Pythagoras Apollonius theorem. So I'll say in triangle ABC, if I apply the Pythagoras Apollonius theorem, I will say AC square plus BC square. So that will be AC square plus BC square is equal to 2CD square. So 2CD square plus 2AD square. 2AD square. I also write down the reason Apollonius theorem. Then let us substitute the values. AC is given as AC is given as 7 plus BC is 9, 2 CD square we don't know, and AD is 5 we have just found out. So 2 into 5 square. Let us substitute 49 plus 81 is equal to 2 CD square plus 2 into square of 5 is 25. So 9 plus 1 gives you 10 This is 130. 2 CD square is plus 25 into 2 will be 50. So I want to find out what is CD square. So I'll keep this alone. I'll bring 50 on the other side. 130 minus 50 is equal to 2 CD square. So 130 minus 50 is going to be 80. So 80 is equal to 2 CD square. Now, so let me solve here. 80 upon 2 will be CD square. So this is going to give me 40 is equal to CD square. Okay. Now, I want to find out only CD. So I need to take the square root of 40, which is like this. Now let us solve for, let us find out what is the square root of 40. See children, those who can do it directly, we will say that the square root of 40 we are going to write down as 4 into 10. But if you can't do that, one easy method to do this is find out the factors. Okay, find out the factors of 40. 2 2s are, 2 10s are, 2 5s are, and 5 1s are. You do this and then you write down it here. It's 2 into 2 into 2 into 5. So in the next step, you'll make the pairs of two similar numbers. So this will be my pair of similar numbers. So in the next step, the square root will disappear for this, and I'll write down only one single for this two. Okay. Then these are not the similar numbers, so they remain under the square root sign like this, and hence the answer is 2 root 10. So from here we get our answer as CD. Therefore our CD is equal to 2 root 10. This is our final answer. The new question, it says that in the given triangle, PS is the median. PS is the median, that means S is the midpoint of this QR, and PT is perpendicular to sec QR. We have to prove this. Let us see how are we going to start this. Children, when we look at this, what we have to prove, we find there is PR square. Now let us check where is PR in our triangle. In this triangle, PR is somewhere here. Okay, and if I apply Pythagoras theorem to this triangle, I can get PR square is equal to PT square plus TR square. Yes, so I will say in triangle PTR, PT is perpendicular to QR. Or else you can also say that since PT is perpendicular to QR, we can say that angle PTR is equal to 90 degrees. Therefore, PR square is equal to PT square plus TR square. This will be because of Pythagoras theorem. PR square, I can do nothing about it. I write it down again. PT square, I write it as it is, plus TR. Children, TR I can write down it as TS plus SR. Yes, TR is the addition of these two segments. So instead of TR, I show that TR is equal to TS plus SR, and there is a square, so this. You also mentioned the reason, since T dash S dash R. S is in between T and R. Now, after getting this, let us expand. PR square is equal to PT square plus. What about this? In the lower classes, we have studied in identities A plus B the whole square. A plus B the whole square is A square plus 2AB plus B square. Right? We have studied this in lower classes. A plus B the whole square is equal to A square plus 2AB plus B square. Let us use this formula for this. So according to this will be A square. So TS square plus 2 into TS into 2 into TS into SR plus SR square. Okay. Now, after doing this, PR square I needed, PT square I don't need it somewhere, but I cannot do anything with it right now. So let us stop here. And then TS. What can I do about TS? Let us check it later. 2 into TS. Into TS I needed, see here, TS. So I'll keep it as it is SR. I don't need SR anywhere. Instead of SR, no, I have QR. I have QR. So children, looking at this figure, can I say that SR is half of QR? Since S is the midpoint, this is going to be half of QR. Yes. So I'll say in the next step, therefore PR square is equal to PT square as it is, TS square as it is, plus 2 into TS into SR. SR I can write down as half of QR. Yes. So I'll write down this as QR upon 2. QR upon 2 plus QR upon 2 the whole square. Yes, because SR is half of QR. I can show the reason in the bracket. Since S is the midpoint of side QR. Okay. Then in the next step, can now just look at the other part. If once I've got PR square, we'll stop here. Now let us check PS square. From where did I get PS square? PS square is here. If I apply Pythagoras theorem to this smaller triangle, this one. If I apply Pythagoras theorem to this smaller triangle, only this much, I can say that PS square is equal to PT square plus TS square. So I'll do that in the next part. I'll say in triangle PTS, angle PTS is equal to 90 degrees. Okay. Since it is 90 degrees, I'll say PS square. I'll say PS square is equal to PT square plus TS square. The reason will be Pythagoras theorem. Just see here, children, this one. If you look, this PT plus TS is somewhere here. Yes. So instead of PT plus TS square, if I write down this here, I'll get some other statement. Yes. So for that, what will I do is, I'll write down this as equation 1 and this I'll put as number 2. So I can say from 1 and 2, from 1 and 2, I can say that PR square I write down as it is, this PS will be equal to PT plus TS square. So instead of this, here I am going to write down this PS square plus 2 into TS into QR upon 2 plus QR upon 2 the whole square. Now just look here, we can cancel 2 and 2 here. Yes, and the last step we get PR square is equal to PS square plus TS into QR plus QR upon 2 the whole square. That is what our question says. PR square is equal to PS square QR into ST plus QR upon 2 the whole square. Similarly, we have the second question to prove. We have to prove that PQ square is equal to PS square minus QR into ST plus QR upon 2. Now, so before we start solving this, what I do is I write down set PS is median, which is given to us. Since set PS is a median, S becomes a midpoint, and therefore QS is equal to SR, and these both are half of entire QR. So that's what I have written. QS is equal to SR, and that is half QR. Half QR can also be written as QR upon 2. Now, how do I solve this? So check, what do I want to prove? I want PQ square. So first PQ square. If I want PQ square here, I can get it by applying Pythagoras theorem to this triangle, children. Yes, and therefore I will apply Pythagoras theorem to this triangle, and in triangle PTQ, angle PTQ is equal to 90 degrees. It is very important to show that the angle in a triangle is 90 degrees, and then only you can proceed further to apply the Pythagoras theorem. Okay, so PQ square is equal to PT square plus QT square. So that is because of Pythagoras theorem. Then PQ square, I'll keep it as it is because I want it in my question. PT square plus QT square, what can I do with it? So I can say QT is QS minus TS. Yes, QT will be QS minus TS. So like that I am going to write down it in the next step. PQ square is equal to PT square plus, instead of QT I'll write down QS minus TS the whole square. Yes, and in the bracket I can add down, since T is in between Q and S. Okay, now in the next part, let us expand this. PQ square is equal to PT square plus, children, this is A minus B the whole square formula. A minus B the whole square, which is A square minus 2AB plus B square. So we'll expand this in this form. So A square, so QS square minus 2 into QS into TS plus TS square. Okay. So we'll keep all that, and let us see now what all things can be changed. So now I cannot do anything with this, so I stop here, and I'll number this as 1. I number it as 1. Now let us check what is the other part that I want here. Now next part that I want is PS square. So PS square will be equal to PT square plus TS square. Yes, so I'll say in triangle PTS, angle PTS is equal to 90 degrees. Therefore PS square is equal to PT square plus TS square. Pythagoras theorem. You cannot do anything to this, so you can just number this as 2. Number it as 2, and there. Just see what can you do here. See, if I try substituting PT plus TS, see children, PT plus TS square is here. So instead of this PT plus TS square, if I write down PS square, so I'll say from 1 and 2. Okay, from 1 and 2, I will get PQ square is equal to, now instead of PT square plus TS square, I am going to put PS square. So PS square plus QS square minus 2 into QS into TS. Okay, so this is what we have got till now. So now, what else can we do? I want PQ square, which I have got. I want PS square, which also I have got. QR into ST, which QR into ST, it's here. Okay, QR into ST. And what about QR upon 2? It's not there, right? So that is what we are going to solve first. I'm sorry, here I have written 2 into QS. We have to write down QS here. That is my mistake. Okay. Now, PQ square is there, PS square is there, QS I don't want. I want to replace this QS. So this QS can be written as QR upon 2. Yes. So we will say, therefore, PQ square is equal to PS square plus, instead of QS, I'm going to write down it as QR upon 2 the whole square minus 2 into QS. Our QS is QR upon 2 into TS. So let us write down it properly. PQ square is equal to PS square plus QR upon 2 the whole square. This 2 and this 2 cancels and we are left with QR into ST. This is what our question is. If you check here, PQ square, which we have got, PS square plus QR upon 2 the whole square and minus QR into ST. So we rearrange it and write it properly. PQ square is equal to PS square minus QR into ST plus QR upon 2 the whole square. Next question is very easy. In triangle ABC. So the given triangle, in the given triangle, point M is the midpoint. Point M is the midpoint, which means that AM will be the median. Yes, and AB square plus AC square is 290. AM is equal to 8. Find BC. See children, they have given us AB square plus AC square, which gives us a hint here that we can make use of Apollonius theorem. Yes, so and Apollonius theorem is used when you have a median in a given triangle. So first thing that I need to write when I solve this question is, in triangle ABC, seg AM is the median. I write down it as given. Seg AM is median. Therefore, AB square plus AC square, AB square plus AC square will be equal to 2AM square plus 2BM square. Yes, these are the two things that we are going to write. But if you look here children, we have AB square plus AC square, we also have AM square. We don't have BM square, but we also need to find out what is BC. So all these things we need to remember and we have to proceed ahead. Now, before doing that, it is very important to write down the property Apollonius theorem. Now, AB square plus AC square is 290. So 290 is equal to 2 into AM square, which is 8 square plus 2BM square. Let us solve this. 290 is equal to, the square of 8 is 64. So 2 into 64 plus 2BM square. Now 290 is equal to, you can multiply this 2 into 64. So let us do that. 64 into 2, which will give you 4 2s are 8 and 6 2s are 12. 128. So this will be 128 plus 2BM square. So 290 minus 128 will be 2BM square. Let us subtract 290 and 128. This will be 8. It will give me 7. So 128 plus 172. So this will be 172 is equal to BM square. This 2 comes here. So it's been multiplied. When it comes here, the operation is opposite. So 172 upon 2 is equal to BM square. When you divide this, you will get 2 8s are 60 and 2 6s are 12. So BM square is equal to 86. I'm just sorry with the calculation here. See, a minor mistake can change your entire answer. Okay, now here 10 minus 8 was 2. This was 6. Yes, and this is 1. I'm so sorry. So this becomes 162. This becomes 162 upon 2, and this becomes 2 8s are 16 and 2 1s are 2. So this BM is going to be square root of 81. So BM will be 9 centimeter. But we are not supposed to find out what is BM. We are supposed to find out what is BC. But once I get BM, I can easily find out what is BC. Now, I will say BM is equal to MC, and that is equal to BC upon 2. Can I say that? BM is equal to MC, and that is equal to BC upon 2. BC upon 2 means it is half of BC. Okay. So, and we need to give a reason here, since M is the midpoint. Since M is the midpoint, which is given to us in the question. So now, I will take whatever is given to me. So BM I have, so I'll write down. BM is equal to BC upon 2. So BM, what is BM? 9. So 9 is equal to BC upon 2. So if I need to solve this, what will you get? This 2 comes here. So 9 into 2 is equal to BC. So 9 2s is 18 is equal to BC. Therefore, BC is equal to 18. But there is a unit given centimeter. So we write down BC is equal to 18 centimeter. This is your final answer. Okay, the next question is quite tricky one. The only thing that is given in this given figure is that quadrilateral PQRS is a rectangle, and you have to prove that. And one more thing that they have given is AB is parallel to SR. This is what is already given in the question. Okay, so I'll just write down whatever is given. I'll say given quadrilateral PQRS. PQRS is a rectangle. So this is given to us. Construction is seg AB is parallel to side SR. This is the construction. Okay, only these two information is given to us, and we are supposed to prove that TS square plus TQ square. So let us check where is TS. TS square plus TQ square is equal to TP square plus TR square. See children, when we look at these TS square, TQ square, TS square, TQ square, TP and TR square, we can say that we can easily get this by applying Pythagoras theorem. To TS square I'll get when I apply the Pythagoras theorem to this triangle. TP square I'll get if I apply to this. TQ square from this and TR square from this. But the problem here is there is no 90-degree angle mentioned here. We haven't been told here that this is perpendicular or this is 90 degrees. Nothing in such kind of information is provided to us. So first we are going to show that this AB is perpendicular. We are going to show these four angles to be 90 degrees. Once we get this, then only we can apply the Pythagoras theorem to get our answer. So let us see how are we going to do that. Okay, so the proof. Let us start with the proof. The first thing that I'll mention is that seg AB is parallel to side SR, which is given from the construction. And see, first thing I'll write down, seg AB parallel to side SR, reason will be construction. Okay, I'm so sorry I did not mention the side SR. Seg AB is, this will be the construction. Okay, next part. sec AB, this is construction. Also sec PQ will be parallel to SR, children, since these are the opposite sides of the rectangle, and the property of a rectangle says that the opposite sides of the rectangle are always parallel and equal to each other. So from that I will say sec PQ is parallel to side SR. Sides of rectangle. So looking at this, AB is parallel to SR and PQ is also parallel to SR and PQ is also parallel to SR. So automatically I can say that if this is parallel to this and this is also parallel to this, that these three lines are parallel to each other, and therefore I will say sec AB is parallel to side PQ and parallel to side SR. Okay, this will be our first part. Now, the next one. We will also say that BQ is equal to AP and BR is equal to AS. I'll say BQ is equal to AP. Why? I'll tell you. BQ is equal to AP and BQ, this part. BQ is equal to AP and BR is equal to AS, because whenever there are two lines which are parallel, then the distance between these two lines are always going to be equal. So if these are the two parallel lines, so this perpendicular lines will be equal. Okay, so that's why I'll say that BQ is equal to AP and BR is equal to AS. Then we'll say distance between two parallel lines are equal. So this is our first part. Now we can also name this as number 1. So we'll number it as 1. I'll number it as 1. Next, I will say now if AB is parallel to SR. Now look at this. Now if AB is parallel to SR, and see if AB is parallel to SR, okay, and if these two are the transversals, then can I say these two angles are equal? Also I can say that these two angles are equal. Okay, why can I say that, children? Because they are the corresponding angles. So I will say that this angle is equal to this angle, this angle, these two angles. But then since this angle is 90 degrees, this also is going to be 90 degree, and automatically we are going to show that this is perpendicular. Okay, but before that, how are we going to show that? We will say that PS is parallel to QR and these are the transversals, or else the other way to do that is AB is parallel to SR. AB is parallel to SR, and if these are the transversal, then this angle is congruent to this and this angle is congruent to this. But we know that these are the rectangle, so these angles are 90 degrees and therefore this angle will also become 90 degrees. Okay, so that's what we are going to write down in our answer. Let us write that. We will say that we will write down AB is parallel to PQ. AB is parallel to SR, and PS and QR, side QR and PS are the transversals. Therefore, angle PSR you can say, or angle ASR, whatever way you want. Okay, so I'll say angle PAB is equal to angle ASR, and angle QPA is equal to angle BRS, corresponding angles. But PAB we don't know, but I know ASR. Yes, ASR is 90 degrees since it is the angle of a rectangle. So automatically PAB will also become 90 degrees. So I'll say PAB is equal to ASR is equal to 90 degrees and QBA will be equal to BRS. But BRS is an angle of a rectangle and it is 90 degrees. So there are four angles which are 90 degrees: PAB, ASR, PAB. So this angle has become 90 degrees now. ASR is 90 degrees already. QBA has become 90 degrees and BRS is always a 90 degree angle. Now you can number it as 2. This you can number it as 2. Okay. Now let us proceed further. Now we will say in triangle TBQ. In triangle TBQ, we'll find out what is TQ square. We are going to take one by one all these square triangles now. We will take triangle TBQ, from where we'll get TQ square. We'll take triangle TAS, from where we'll get TS square. We'll take this triangle and we'll get TP square, and we'll take this triangle and we'll get TR square. So let us do that one by one. Now I have applied Pythagoras theorem to all these four triangles to get PT, ST, QT and TR, and that's what I've got. In triangle TAS, TS square is equal to 8TA square plus AS square. Similarly TQ square I've got. TQ square is equal to TB square plus BQ square. Okay. Then in triangle PAT, I've got PT square is equal to PA square plus AT square, and last I have got TR square. TR square is equal to TB square plus BR square. So I have applied Pythagoras theorem and this is what I get. Now, next step. Now, in the next, after adding TS square and TQ square, we get TA square plus AS square. See, I got four various sides using the property. Now I am adding those, and when I add those, I get TA square plus TQ square is equal to this, and TP square plus TR square is equal to this. That is because of this question. It's in the question, it's given TA square plus TQ square, so I added those, and also it was given this, so I added these two. When I added these, I got right hand side as these part. If you look here, TA square and TA square is same. AS and PA we don't know. TB is again the same. Now, what about this AS and PA? Children, if we check at AS and PA, we have told in the beginning only that these two are equal because these are the distances. Yes, this AS is equal to PA. Okay, and also BQ is equal to BR. BQ is equal to BR. So now let us check what about this AS and PA. AS and PA, children. For AS will be equal to this AS is going to be equal to BR. This AS is equal to BR. Why? Because these are the distances between two parallel lines, and we have PA square equal to BQ square. We have PA square equal to BQ square because these are also the distances between the two parallel lines, and therefore this is equal to this, this is equal to this, this is equal to this, and this is equal to this. Automatically we can say, therefore, from 1, 3 and 4 we have TA square plus TQ square is equal to TP square plus TR square. Hence, it is proved.